Halfpipe skiing is a competitive sport in which athletes perform aerial stunts from one side of the pipe to the other. It is used in competition rated by judges or for shots of top athletes pushing the sport to new heights. Here we have Simon Dumont, one of the world's top skiers.
When Simon is on the back of the snowmobile, if he were to throw an object in the direction they were traveling, the object would be traveling as fast as it was thrown relative to the snowmobile. If someone was standing and saw Simon throw it, they would see it travel the speed of the snowmobile plus the speed Simon threw it relative to the ground. When Simon drops into the inrun of the pipe, he travels at a constant speed for 25 meters in 5 seconds. Knowing this, we can calculate his average speed at 5 meters a second. Since we know that acceleration is the change in velocity per unit time, we can find Simon's acceleration from the starting point of his inrun to the point of constant speed.
Friction is an opposite force to an object in motion. Anytime Simon is in motion, there's friction. There's friction on the bottom of Simon's skis as he goes, and there's air friction on his body as he's in motion.
We know that work is the changing of the position of an object through an applied force. When Simon Dumont jumps over the lip of the halfpipe, he is applying force to lift his body up 1 foot so he can enter the halfpipe.
Kinetic energy is the energy an object has due to its motion. Potential energy is an energy that is dependent on the position of an object. As Simon is at the peak of his jump, he has the highest possible potential energy. When he comes down from the jump, his kinetic energy increases as his potential decreases. When Simon is floating in the air, the force of him moving his body is unbalanced, causing him to spin. At the height of his jump, the force of gravity is unbalanced and pulls him down. The force of his unbalance, an object will increase or decrease in motion. We can predict that an object with a higher mass will have more momentum than an object with a lower mass.
Areas of pipe that don't exist when they normally do.
When Simon hits the top of the pipe, there is an equal and opposite force that comes from the pipe. When Simon is on the ground, the force of gravity and his body pushing up in the opposite direction are balanced. When he is skiing, the force of gravity and the opposite force of his body keep him on the ground as well. If motion is constant, the forces are balanced.
If motion isn't constant, there is an unbalanced force. In the absence of an unbalanced force, an object at rest stays at rest, and an object in motion stays in motion. There must be an absence of an unbalanced force for forces to be balanced. An object with higher mass has more inertia. If Simon had double the mass, he would have higher inertia, and it would take stronger opposing force to stop him. Momentum is the product of the mass and the velocity of an object. We already found that the velocity of Simon as he comes down from the jump is 16.7 meters per second. Using this, we can calculate his momentum.